Hey everybody, welcome to Algo Expert. In this video, we're going to be covering the question of the largest range. This is a question that I really like because it's pretty simple to understand, and it's got two solutions. One which is pretty easy, if not even obvious. It comes to your mind pretty quickly. The other one is a lot more difficult. It's a lot more clever. And it happens to be more optimal, at least from a time complexity point of view. And it's the one that we're going to be digging into now. So for this question, you're given an array of integers, and you want to find the largest range of numbers that is contained in this array. So a range of numbers is basically a set of numbers that come one after another in the set of real integers. So for instance, the range from 2 to 5 consists of the numbers 2, 3, 4, 5. And here in the array, if you look at the example array that we've got here, a range doesn't necessarily have to have all the numbers next to each other in the array. The numbers in that range simply need to be contained somewhere in the array. And so for this example, the largest range happens to be the range from 0 to 7, because you've got the numbers 0, 1, 2, 3, 4, 5, 6, and 7. You've got also a couple of other ranges in the array. You've got 10, 11, and 12, and then you've got just the number 15. But these are smaller than 0 to 7. And so how do we come up with this solution? Well, I mentioned earlier that there's an almost obvious way to solve this, which is to sort the array, right? We could sort this array, and once the array is sorted, we could loop through it, make sure at every number that the previous number in the array is just equal to our current number minus 1, right? And we'd be able to keep track of all the ranges, all the valid ranges in the array that way, and then we could, keep track of the longest one pretty simply after that. I'll leave it up to you to figure out how to implement that in code. But that would be one way to solve this problem. Now, because it would involve sorting the array, it would take n log n time. And n log n time might not be the most optimal solution here from a time point of view. And what should really give that away is the fact that you came up with this solution really fast, right? If you were in an interview, you might have come up with the solution that sorts the array first in a couple of minutes, and you'd have to ask yourself, can I do better? Or your interviewer would probably ask you that. And so you can do better. How? Well, if we don't sort the array, we can imagine that we're going to have to somehow access each and every one of these numbers in this input array really fast, right, at a moment's notice. So perhaps it might be useful to have a hash table and to store all of our numbers in a hash table. So that's what we're going to do. We're going to store all the numbers in a hash table. I'll write the hash table here on the side, and we'll just put all of the numbers. 1, 11, 3, 0, 15. Then we've got 2, 4, 10, 7, 12, and then we've got the number 6. Okay, so that's our hash table. And for now, it doesn't matter what all of these numbers map to. We're just going to store them in a hash table, and we know that we can access them in constant time. So what can we do with that? Well, let's say we iterate through our input array, right? And we start at the number 1. What we can then do is we can try to explore the range that 1 is located in, or the range that 1 is contained in, that is in the array. How can we do that? Well, we can start traversing through all the numbers that are smaller than 1 and checking if they're contained in our hash table. And similarly, we can start traversing all the numbers that are greater than 1, just in the set of real numbers, right? And see if they're located in our hash table. So let's go through that example and see if that makes sense. So our current number is 1, right? This is our current number. So what comes before the number 1? Well, we've got the number 0. Is 0 in our hash table? Yes, it is. It's right here. And we can, or meaning it's in our hash table, and therefore it's in our array. So we can access it in the hash table in constant time. Then what comes before 0? -1. Is -1 in our hash table? No, it's not. We can make sure the -1 is not in our hash table and therefore not in our input array in constant time. So we're going to erase -1, and we're going to just say that our current range, the range that the number 1 is contained in our array, ends at the number 0. That is the left extremity of the range. So we've got 0 and 1. Now we go to the right of 1. So we would have the number 2. In fact, let me erase this circle here just so that I give myself a bit more space. So we've got the number 2. Is the number 2 in our hash table? Yes, it is. It's here, meaning it's in our input array, so we can keep it. Now we go to the number 3. Is 3 in the hash table? Yes, it is. That means it's in the array. Then we go to the number 4. It's in our hash table. 5, it's in our hash table. 6, it's in our hash table. And 7 is in our hash table. And I just realized I forgot to put the number 5 in our hash table, but it should be. We'll add it here. 5 should be in our hash table. So we have all these numbers that constitute a range. They're in our hash table and therefore in our array. Now we get to the number 8, and 8 is not in our hash table. So we know that we're done with the range. The range that the number 1 is contained in starts at 0, ends at 7, and it is contained in our array. So we're going to mark that as kind of complete, and we're going to move it and maybe store it just, at the top, and keep that in mind. That's a potential largest range in our array. Okay, fair enough. So now we move to the next number. We've got the number 11. So 11 could be part of a range, right? And we look at the number to its left, the number 10. Is the number 10 in our hash table? Yes, it is. Okay. Is the number 9 in our hash table? No, it's not. So the number 9 is not in our array. So the leftmost extremity of the range with the number 11 is the number 10. Okay, so now we move to the right. We look at the number 12. 12 happens to be in our hash table and in our array. And then we go to the right again to the number 13, and 13 isn't. Okay, so we've got another potential range, which only has 3 numbers, 10 through 12. And it happens to be smaller than our other range, but let's just keep it here for the sake of argument, or for the sake of good order. Okay, now we move on to the third number in our array, which is the number 3. And here, this is where things get interesting. Because once we're at the number 3, we could do the exact same thing that we just did, and start, expanding to the left of 3, expanding to the right of 3, looking in our hash table and seeing what numbers would constitute a range that contains 3. But you'd quickly realize that we'd get the exact same range that we found earlier. So it wouldn't get us anywhere, and we'd be repeating work. And if we continue doing that throughout the entire array, we're going to be left with a lot of work to do. Like, at every number contained in this big range here, we'd be doing the same work. So we'd be iterating through all the numbers a ton of times, and that doesn't seem optimal at all. So what can we do? Well, we've got a hash table, right? And I mentioned at the beginning not that we shouldn't worry about what these numbers in the hash table map to, but maybe it's time that we should, right? So what we can do is we can have every number in the hash table map to a Boolean. And that Boolean is going to tell us whether or not it's good or it's correct to still explore that number. So let me show you. We'd start by having all the numbers point to the Boolean true. And here, you could choose whatever value you want. I just think, using true and false kind of makes sense to me. So we'll have all the numbers mapped to true at the very beginning when we fill up our hash table. And what this is going to do, let me move this little bracket here to give myself some space. What this is going to do is it's going to tell us that all of these numbers so far are good to go to explore, right? And so if we take a step back and go back to the beginning of our array and start iterating through it and start doing this thing where we found the two ranges here, whenever we explore a number and we find it in the hash table, we change its value from true to false. So we started with 1, right? And 1 was in the hash table. So we change this value from true to false, okay? And then we do that with the number 0, because 0 was the next number that we found. And then we went to -1, and -1 just wasn't in the hash table, so we stopped there. And then we started going to all the numbers that were greater than 1. So let's go through all of them very quickly. We've got 2, 3, 4, 5, 6, and 7. And we're going to mark them all as false. So false, 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 and false. Then we went to the number 11, and we went through 10 and 12. And we stopped at 9 and 13 because they weren't in the hash table. So let's erase 11, 10, and 12, and let's replace them with false. And now you'll notice that nearly all of the numbers in the hash table are marked as false. And so what that does to us is when we get to the next number, which is 3 here, we can just check, wait a second, is this number marked as false in our hash table? If it is, we've already explored it, and we don't want to explore it anymore. It's no longer good to go. So we skip it. Then we go to the number 0. Is it marked as false? Yes, so we skip it. Then we go to the number 15. Is 15 marked as false? No, it's marked as true. So we go through the same exercise. 15. Then we look and we erase the true here and put it to false, right? And then we go through the numbers before and after it, so 14 and 16. And we notice that neither 14 or 16 is in the hash table, so we stop. And so we've got here a range, a potential range that only has the number 15. And this range obviously is not bigger than 10, 11, 12, which itself is not bigger than 0 through 7. So we can actually erase both of these ranges. And so you'll notice that, by the way, when we got to the number 11 here, the second number in the array, 11 was marked as true back then. And then we marked it as false. That's why we did the whole expanding and finding the range with the number 11. But so now we move on from 15 to 5. 5 is already marked as false. 2 marked as false. 4 marked as false. And then 10, 7, 12, and 6 are all marked as false. And so we don't do anything for them. And then finally, we are left with our final range, 0 to 7, which is our answer. So you can see, you're starting to see the beauty of this approach, right? We store everything in a hash table. Every number in the array is stored in a hash table, and every number points to the Boolean true at the beginning, or whatever value you want that makes sense to you, that has some meaning. Here, true means that we are good to go to explore these numbers. Okay? So then we start iterating through our array, and at every number we check, is that number marked as true or false in our hash table? If it's marked as false, that means that we've already explored it, so we skip it. If it's marked as true, then we start to expand outwards and check the range that it's contained in. And when we expand outwards, for all these new numbers that we explore as we expand outwards, we check, first of all, are they even in the hash table, right? And that's a constant time operation to check if the number is in the hash table. If it isn't, then you just forget about it and you're done with that expansion. Like you found your extremity for the range. And if it is in the hash table, you mark it as false. It's a new number that you're exploring. And then once you've found your range, right, you found the two extremities of your range and you're done expanding, you check it against your current candidate for the longest range. And then lastly, you continue iterating through the array. And at every number, you check if it's even worth exploring again by checking if it's already been explored. In other words, has it been set to false in the hash table? And so what that means is that you're not doing unnecessary work, right? So for the numbers, 3, 0, 2, 5, 4, 6, 7, we ended up exploring them twice. Once when we expanded from the 1, and then once when we just walked through them, but we didn't do anything at them, right? And so that tells us that the time complexity of this algorithm is going to be O of n time rather than O of n log n time for the sorting approach. To make sure that we're on the same page here, it's O of n time because we first iterated once through the array and put everything in a hash table. And then we reiterated through the array and we went through all the numbers around, about one time, right? We went to the number 1, then we expanded outwards and found the numbers 0, 1, 2, 3, 4, 5, 6, 7, marked them all as false. And then every time that we got to each of those numbers, we just didn't do anything anymore, right? So we did very little work. And similarly for, 11, 10, 12, and then finally the number 15. And so that's why we've got O of n time. By using this hash table to mark certain numbers as false, we are no longer doing unnecessary work after, and that gives us a time complexity of O of n time. We also have a space complexity here, because we do have to store stuff in a hash table, but that space complexity is just going to be O of n space, because we're storing every number in the hash table. And that's that. And I guess I will note that whenever we store the range, we don't necessarily have to store the entire range, right? We can store just the starting number and the ending number, which is constant space. And we can also maybe store the length of the range as an integer value. So like our range has length 7 or no, maybe it has length 8. And that doesn't use up extra space. So that's why we've got a space complexity of O of n. And that's it. I hope that this conceptual overview was helpful. Now let's dive into the code implementation to see what it looks like. All right, so we've got our largest range function defined. It takes in an array of integers. And the first thing we're going to want to do is initialize a few variables. So we want to keep track of our best range, right? The largest range in a variable. So we'll call that best range, and it's going to be an empty array at first. And this array is just going to hold two numbers, right? The first number in the range and the last number in the range. Then we're going to have a number, an integer, which is just going to hold the longest length of our best range, just so that we can quickly verify whether a new range is the new best range or not. So we'll have longest length, and this is going to be initialized to 0. And finally, we're going to have our hash table. So we'll call this hash table our nums hash table because it's going to hold all the numbers in the array. You could call this whatever you want, right? You could call this visited or something like that. Or explored, or any name that makes sense to you. In fact, you could even have two hash tables, one purely holding the numbers and one holding, the whether or not the numbers have been visited or whether or not the numbers are good to go to be explored. That's really up to you. Here, I'm just going to use one hash table. So then we traverse our array for num in array, and we set every number to true in our hash table. So nums of num is going to be equal to true. That tells us that every number is good to be explored. And then we start, the crux of our algorithm, the bread and butter. So we reiterate through the array for num in array. And the first thing we want to do here is check if the number's already been explored. So check if the flag, right, the value that's being mapped to in the hash table is false. So for if not nums of num, right, if the value in our hash table at the current number is false, it's a falsy value, then we can just continue and skip that number, right? So again, here we're saying if the value is false in our hash table, then the number is not good to go and we skip it. Otherwise, well, we set that value to false because now we are exploring this number. And we set the current length, right? The current length of our range, because now we're going to be kind of expanding outwards and trying to find a candidate for the largest range. So we set the current length to 1. Because so far we've got one number, the current number. And then we can set the left number to be equal to num minus 1, and the right number to be equal to num plus 1. And we're going to start expanding these numbers and seeing whether or not they're contained in our hash table and in our array. So we can say while left is in our nums hash table, right? While the left number is in our nums hash table, which means that it is in the input array, we set its value in the hash table to be false, and we increment the current length, because that means that we've got a range that's one number bigger, and we decrement left, because we continue to expand to the left. And we can do the exact same thing for the right number, right? While right our right number is in the hash table and therefore in the array, we set that number to false because we're exploring it. We increase the length by 1, and we increase the right number by 1. Okay? And so by doing this, right, by setting all these numbers to false, we know that when we loop back through them later on, right, on line 7, and then on line 8, we're gonna hit this conditional statement here on line 8. It'll be correct, and so we'll hit the continue statement and we'll skip those numbers, right? And we also know for a fact that any left number or right number that is in nums hasn't been explored yet, right? Because if it had been explored, we wouldn't have even hit a number in its range, right? Because we would have explored all the numbers contained in the range that number is contained in. We would have marked them all as false, and so right now we would be in a brand new, like, separated range, if that makes sense. Okay, and so now, once we're out of these two while loops, we can just check if our new range is worthy of being the best range, the largest range, by just checking the current length, right? If current length is greater than the longest length, then we can increase the longest length to be equal to the current length, and we can update our best range. And so what is our best range going to be? Well, it's going to be the left extremity of the range and the right extremity. So it's going to be left plus 1 and right minus 1. Why are we doing this plus 1 and this minus 1? Well, we were in the while loop, right? While left in nums, we do all of these things. Eventually, we decrement left to the point that it's no longer in nums, meaning the leftmost number that was in nums is equal to left plus 1, right? So let's say in the example that we did in the conceptual overview where the range was 0, 7, right, we would get to a point where left minus equal to 1 is equal to 0 minus 1 is equal to minus 1. And minus 1 would not be in the hash table. So the leftmost extremity of best range would be left plus 1, which would be negative 1 plus 1, which would be 0. And same logic for the right number. And so finally, when we get out of the loop, the for loop, we can just return the best range. And we're done. This algorithm is going to run in O of n time, and it's going to run in O of n space, because we are storing every number in a hash table. That's going to be O of n space. And then O of n time to actually store them in the hash table, right? Iterate through the array once. And then another O of n time for all of our logic. And the O of n, the fact that we don't go above O of n, stems from the fact that we have these booleans here. The fact that we mark the numbers in the hash table as false and then never explore them again. So that is it for this algorithm. I hope that it was helpful. I hope that you were able to learn a lot from this one. It's a really cool algorithm. Definitely teaches you a lot about arrays, about hash tables, and I'll see you in the next one.